welcome to a new video. In this video, we're still talking about object-oriented programming using Java, and today we're going to talk about polymorphism. Now, polymorphism was one of those confusing topics that I personally found it really hard to understand. The syntax is not complicated, but the idea was a little bit hard to imagine or understand what is it and why is it used for. Today I'm going to explain the idea using examples, hoping that it will make it a lot easier. So let's start. So first of all, let's take an example, a real life example about a character. So we have Homer, and Homer basically is a man. Now I said here, forget about who is Homer and how he acts usually. I hope everybody here who watched this video actually saw Simpsons before, or at least one episode of Simpsons. So Homer is a man. He can be described as a man. He has the characteristics of a man. He acts as a man. So that's what Homer is. So at the same time, Homer is a husband. And also, Homer is a father. And also, Homer works, so he's an employee somewhere. And then after he comes back from work, he's a neighbor. So, as you can see here, Homer, the man, is also a husband, a father, an employee, and a neighbor. So, let's get into more detail about this Homer guy. Homer the man can take many forms. As you can see here, one time he's a husband, the next he's a father, after that he's an employee, and then after that he's a neighbor. Homer, the man, he basically acts depending on the situation he is in. So sometimes he's a father when he's he's a father when he's dealing with his son, and he's a husband when he's dealing with his wife, and he's an employee when he's at work, and he's a neighbor when he deals with his neighbor. So as you can see here, this Homer guy can take many forms. Now let's talk about polymorphism and how is this related to polymorphism. The word polymorphism basically means many forms. And as you can see here, there's a sort of connection. So polymorphism by itself, it means many forms. Now let's try to understand this example from an object-oriented programming perspective. Polymorphism basically means having an object, in this case he's a Homer, which belongs to a class, and this class is called man. This object, which is Homer, can take many forms depending on the content, and that's basically what polymorphism. So polymorphism, basically, when you have an object and that object acts differently, act like it belongs to different classes, depends on the situation that object is in. And in object programming, we like to call it the content of the object. So the baseline is Homer is a man, but again, he can actually act as a man, and he also acts as a husband, and he acts as a wife, and he acts as a father, and he acts as an employee, and he acts as a neighbor. So it's one object that takes many forms, and that's what basically polymorphism is. Let's go ahead and keep going and start trying to understand how is this example related to object-oriented programming. So let's think of this picture here. We have a superclass called man. Out of that superclass, we create an object, which is Homer. And then we have other subclasses. We have the subclass called husband, subclass called father, a subclass called employee, and a subclass called neighbor. All of those subclasses are going to inherit from the man class. and then polymorphism is basically creating an object which is a man, and then he can act as a husband when you need him to act as a husband. He will act as a father when you need him to act as a father, and he will act as an employee when you need him to act as an employee, and he will act as a neighbor when you need him to act as a neighbor. And that's what polymorphism is all about. Having one object, which is Homer in this case, that belongs to one class, which is man in this case, that can act in a different forms. So let's keep going with object-oriented programming to understand how it works. So basically, we will create a superclass called man, and then we will have subclasses: husband, father, employee, and neighbor. Those subclasses, of course, they're subclasses because they inherit from the superclass called man. Now, imagine there is a method inside the superclass called act, which basically define how a man will act. And then you're going to override that method in the subclasses. And for example, the act method inside the husband class is going to be how a husband will act. And the act method inside the father class will be how a father will act. And then the same thing for the employee and neighbor. So here it is. This is polymorphism. You go at the top. Let's look at the top here. You can see the mouse here. A man, that's the name of the class. Homer, that's the object. New man. So basically, I created a class, an object that's called Homer, and that Homer belonged to a man. Now, after that, I called a function called act using the object Homer. So basically, the act method inside the class man is going to be executed, which basically define how a man will act. Right after that, and look what I'm going to do here. Still have the object Homer equal new husband. So now Homer is going to start acting as a husband after this. So when I call the function act, Homer no more is going to act as a man. He's going to start acting as a husband. And again, after that, the new situation started, and he started dealing with his son. So he need to be a father. So I'm changing his characteristics or content to be a father at this moment. And then after that, when I call Homer.act, then basically I'm going to ask, basically Homer's going to start acting as the father. Same thing here for employee and same thing for neighbor. Now, one thing I hope everybody realized that without the need for me to say anything is polymorphism heavily depends on inheritance. Like if you don't use inheritance, there's no way you can use polymorphism. And so this is again just me explaining what is polymorphism. Okay, so I hope that example explained everything. Now let's move on to another example. This time I'm going to talk about another movie this time. And I hope you realize that by the look at the picture here. Well, if you haven't seen the movie It, I highly recommend to go and see it. But let's talk about It. Now, It by itself, it's something that nobody knows what it is. You watch the movie. I watched the movie. I hope you watched the movie too. It as an object, it's an evil thing. That's what I can say. But it takes many forms. Sometimes it will appear as a Pennywise, the dancing clown. Sometimes it's going to appear as the woman in the paint. Sometimes it's going to appear as the leaper. And at the end of the movie appeared as the spider. So it by itself can take many forms, as you can see here. And every single form is different than the other. They all scare kids and feed on the fear of kids, but again, in a different way. So let's say if I have a method called attack or fear or scare, you can tell that the scare inside the it, which basically nobody knows what it looks like, but we know how it looks like in all of them. This is going to be basically a good example for the next video. But let's just keep going here. So it by itself. And then we have this superclass, and we have subclasses, which is Pennywise, the woman in the paint, the leaper, and the spider. Now, what I'm going to do after this, I'm going to show you the implementation using this example here, the It movie. Okay, so let's go ahead to the Eclipse, and I basically have, as you can see here, 6 or yeah, 6 classes. The first one contains the main method, and then I have a class called it. Now remember, it is the superclass, and then I have Pennywise, which extends it. So this is subclass. Spider extend its subclass. Leaper extend, and the woman in the paint. So what I'm going to do, again, I'm not going to get into the detail and create a really long class for it. I'm just going to simplify it just to explain how polymorphism works. So just imagine we have a function here, which is public, and it's not going to return anything, so it's going to be void. And then it's going to be called attack. And in this, I'll just put a system.out.print line. And this here, not sure how it attack. Okay, and again, remember, I will use this example in the next video because this is very, very important. This message here is very, very important for the next video. We're going to talk about abstractions and interfaces. So here we go. This is basically a system out print line. Not sure how it, let's put it uppercase, attacks. Okay, this is how simple it is. Now, since all these classes are going to inherit, so basically they all have that attack method. Now, if I come here and say it1, for example, equal new it, put a semicolon, and then after that, I can come here. Well, it's supposed to be uppercase I. Right after that, I can come here and say it1.attack, semicolon. And now let me copy this. Well, you know, there's no need to copy it. I can just choose Pennywise. So Pennywise P1 equal new Pennywise. And then I'll come down and say P1.attack. And again, the same thing. Let's just choose the leaper, for example. L1 equal new the leaper. Put semicolon here. And let's go down, type L1. You know what? I'm just going to do them all. Attack. So I got the leaper. Now we're going to have to go and do the spider hybrid. Copy it. And let's go ahead and do it here. The SH1 equal new. Semicolon, though SH1 dot attack. And finally, we have the woman in the painting. Copy that. Oh, that's going to be a long one. The woman in the painting, PT1 equal new, woman in the painting, and semicolon, and then of course, PT1.attack. Now, so far, there is no polymorphism applied here for a simple reason. I just have few classes are inheriting from one class, and there have the method attack that's inherited. So you would notice that when I call the attack method using each one of those objects, it will basically, come on, did I run it? Nope, I just saved it. Here it is. Not sure how it attacks, not sure how it attacks. Okay, so that makes sense. Now, what is polymorphism? Now, let's try to apply and convert this into a polymorphism case here. First of all, you need to understand that you need to override this method here. So I'm going to copy it. I'm going to paste it inside each one of those. And I do hope that you know what is overriding. Okay. So let's go ahead here. Now, when it comes to overriding, basically you will have the exact same method, exactly everything. The only difference is going to be the implementation. So in the Pennywise, instead of, I don't know how it attack, let's talk about how Pennywise. Creepy dancing big foot. He has a big shoes, not creepy dancing and voice. That's what the attack of Pennywise. Let's just imagine that. Now, spider hybrid. Huge spider. Scary. Not scary. Huge spider. Huge spider. Just keep it simple. Okay, what is this? The leaper. The leaper. Droopy eyes. Scary face. And then let's go to the woman. Long face. Creepy teeth. Okay, again, I don't know how to describe them. I need to go and do a research. I remember them, but okay. So here we go. Let's go back here. It attack. Not sure how it attacked, but again here, creepy dancing and voice. Spider, huge spider. Droppy eye, scary face. Long face, creepy teeth. Anyway, so this is again me overriding all these methods. Now look what I'm going to do here. What I'm going to do, I'm going to take this away, and I'm just going to come here and change it to be it. Uppercase, lowercase t. Let me copy this, and I'm going to put it here. And then I'm going to come here and put this as it. And remember, we put it here. And then you come here and you change this to be it. And you put it here. Just like we did before. We were changing the content of it. And then same thing here. It. Now let's run it. And we'll see what's going to happen here. And you can see here. The first time, let's go back to the definition. Definition is basically to have one object, which is it, that belongs to one class, which is it. And every time you call the method, remember, I'm calling the same method here. It.attack, 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 it.attack. But every time I call that method, a different implementation is happening. And why is that? Because the content of that object is different every time you call that attack method. And this is basically what polymorphism is all about. You want to know another example? For example, we have a person class, and then we have a student and we have a teacher. Let's imagine inside the person class we have a function called work. Now, any person can work, but how exactly they work, well, that's again something I'm going to use as an example in the next class. So I'm not focusing on the super class. But again, when the student is working, basically he will be doing his homework, for example, or maybe in a nightclub or enjoying his time. And for the instructor, when he's doing his job, he probably will be grading his student work, or maybe he will be in the nightclub or something. So as you can see here, we have a person object that could be a student or could be a teacher, and we have a method called work. The work basically is going to be implemented and done depending on which person we're talking about here. Are we talking about a student person, or are we talking about a teacher person? And that's basically what polymorphism is. I hope those examples made it a little bit easier. Next, I'm going to be talking about different topics related to object-oriented programming, but not necessarily related to polymorphism. In general, it's related to inheritance.
Well, hello again. In this part of the video, I am going to talk about multiple topics related to polymorphism and inheritance. And I'm going to use the same example that I had before, the Ed Pennywise example, to demonstrate those concepts. So I'm going to start with the first one, which is a polymorphism in an array of objects. Well, the idea here is we can actually create an array of objects and then assign every single element, and that array of objects basically belong to the superclass. And then for each member of that array of objects, we can assign an object of the subclasses. So as you can see here, this is a 5 elements array for an object called it with uppercase int, and they belong to a class called it. And I can see here for the first element, the second, third, and fourth, for each time I do have, I'm using the new keyword, and I'm calling the constructor of different class. This is acceptable and this is doable, and it's used a lot in polymorphism and object-oriented programming. The benefit of doing it this way, instead of having 5 objects, when you create an array of objects, you can have access to them using a for loop. And in this for loop, every time I'm going to call the attack method, a different implementation is going to be called depending on the value of I here. So that's the first thing I want to talk about now. Now, the second part of this class is going to be more theoretical than demonstration for code or stuff. So the first thing I'm going to talk about is the java.lang.Object. Now, you may not know what is this or where is it coming from, but if you go, for example, here and create a new class, I'm just going to show you what's going to happen. If I go create a new class, this new window is going to pop. Now you can see here, this is where I'm going to type my my class name, but I want you to pay attention to this part here. Superclass java.lang.Object. What is that telling you? That telling you by default, every time you're going to create a new class, that new class that you're going to create here is going to be a subclass, and the superclass for that class is going to be the java.lang.Object. You don't see it, it's not going to be typed, but it's going to be there. And this object class basically contains a lot of methods that we use, and we didn't know about them. For example, the toString is defined in this object class. The equals method is defined in this class, which we're going to talk about in a sec. So this object class basically contains a lot of methods that are useful, and we can use them by default, just calling them, or we can override them, which what we do usually. So this is something that I wanted to mention before we get into more details. So that's basically what object class is. Now, what is a final class? Well, let's talk about the final keyword by itself. When you create a variable and you call it it's a final, that basically means you cannot change it. It's going to be constant. Now, when you create a method and you define it as a final method, basically means you cannot override it. What does that mean? For example, if I come inside it class and I declare a method and I create this method to be final, it's going to be inherited in all these classes, but if I try to change it, override it, it's not going to happen. I'm not allowed to do that. So final basically for methods will lead to that. Okay, so what is a final class? Well, a final class basically it's a class that you cannot inherit from. So if I come to it and I create it as a final class, that basically means all these other classes will not be allowed to inherit from the it class. Again, those are tools that you have and options you have. Just you should know about them, and sometimes in certain applications they become really handy. Okay, now the part that I want to talk about here, and I'm going to demonstrate this, the protected element. Now, what I'm going to do, I'm going to come here to the it class, and I want you to forget about this here. Let me just comment this. Of course, this is going to lead to some issues when I come back here. I'll get some errors. Let's see. Actually, there's no errors, which is not here. I knew that there will be some errors. But let's just keep it simple now. You see, this is a private integer x. Now, because it's a private integer x, that basically means you don't have access to it outside of this class. So if I come here, for example, whereas did I create any objects of it? Here's one. If I'm going to come here and say my it.x equal 10, immediately tell me x is invisible. You don't have access to it. You cannot change it. It's not available for you. So that's basically when I created a private element. And we know that already. Now, when you inherit it class inside those other classes, still the same thing. You inherit x, but you don't have access to x. So if I come here, for example, in this area here, I will type this dot x equal 100. And I should get it. Here it is. Just like I said, x is invisible. It's not visible. You don't have access to it, even though you inherited it from the id class, but you cannot change it. You can modify it. Why you can't? You can't modify it because it's defined as private here. Now, here's the beauty of protected. Protected. I want you to pay attention to this. Since it's protected, I changed it from private to protected. So let's go to the main class here. Now remember, we still have errors here. But if I come here and type my it with a lowercase t dot x equals 0, for example, I'm still, see here. Oh, look at that. Now I can change it if I want. Okay, now let's go back here. And let's go back here and change and do the same thing. This dot x equal 100, and it's still working. Now you may ask the question, well, you changed it from from private to protected, and now you have access to it everywhere. Doesn't that sounds like you changed it to be public? Well, the answer is yes and no. Yes, because you can see that I did have access to it inside the main function. I did have access to it everywhere here. But the answer is no. What does that mean? Okay, I'll explain that. When you declare a variable to be protected, that basically means every single file you have within the packet, within the project. So all these Java files inside this project will have access to that protected element. Okay, so where's the problem then? The problem is if I, for example, this lesson 3 project, if I want to use it and imported it into another project, let's say I create a new project, I call it lesson 4, and I just want to import all these classes as a package into my new lesson, well, in that case, I will not have access to the protected elements. So having a protected element inside a project basically will make it act as a public for all the files or all the classes you have inside that project or packet. But the moment you leave this packet and you move to another project and you try to use your work in this lesson into a new lesson, this is where protected is going to act as a private. So protected basically, if I want to simplify it, it acts as a private and public at the same time. It's public for all the classes within the same package or same project, and it's private for files and projects outside of the project. And that's basically what we mean by protected. So that would be the point of protected. Now, so we talked about the object, we talked about the final, we talked about the protected, and we talked about how you create an array of objects and how you apply the concept of polymorphism to it. Something I want you to think about, do a research about the types of polymorphism. We basically have two types. One of them is called static and dynamic. Static sometimes is referred to the compile time polymorphism, and dynamic is referred to the runtime polymorphism. What's the difference between them? Basically, you should know that there's no syntax. Like you cannot create use a keyword, for example, a static or dynamic polymorphism, but it's the way you actually use the concept of polymorphism will define if it's a static or dynamic. Okay, so now we covered the final class, we covered this, we covered the protected, and we covered this. The two parts left is basically instance of operator and the equal operator. Now we'll start with the instance of operator. instance operator basically it's a tool or an operator that will return a Boolean result, and it check if an object is an instance of a class. So if you have an object, you want to know if that object is basically created out of a class, you basically use this operation. As you can see here in this example, I do have Pennywise PW object, and I created Pennywise here, as you can see. And then I'm checking here. Look at this if statement. If PW is an instance of Pennywise, I'm checking if PW is an object created out of this class Pennywise, then you return true, otherwise return false. Now, I'm going to run it later, but for now I just want to show you that, let me just take those comments away, because I'm going to need them later. I just want to take out the errors. So this will give me a result of true, because actually PW is an object of Pennywise. Now, also, you can check if your object is an instance of a superclass. As you can see here, Pennywise was created out of it class, so this will also return true. This is something you should know. Now, also, at the same time, PW, we know that every time you create a class, object is going to be inherited automatically, so PW is actually an instance of object as well. So those three tests basically are going to be true. This one is going to be true, this is going to be true, this is going to be true. So when is it going to be false? Well, one thing you should know, you cannot compare your object here with any other classes that you created out of your mind. That doesn't work that way. For example, I cannot come here and create a class called Mario and compare it, and there's no relationship whatsoever between the PW and the Mario class and try to figure out if it's an instance of you're going to get a compile error. So when we will get a false case, well, here's a false case, and I want you to pay attention to this. I created my it object, which belonged to the superclass, the parent class it, and I'm checking if this my it is an instance of a subclass. This is a case where no, it's not going to work. You cannot compare an object that belonged to a parent class or a superclass to a subclass or a child class. This is going to return to a false. Also, if you created an object and you assign a null to it, and then you try to figure out if this object belongs to this class. Now look at this example here. Even though when I declared the LEP object as the leaper, but since I assigned it to null, that means the content of this object is null, it's nothing. So when you check if the leap is an instance of the leaper, this will be false as well because there is no content here. And that's the instance of operator. Now, the last part I'm going to talk about here is what we call the equal method. Now, this is going to be a little bit complicated, and you need to pay attention to it here. Now, in Java in general, we have two types of comparison. We have what we call a shallow comparison, and we have the deep comparison. Now, every single programming language uses different strategy when it comes to comparison, but I'm just going to give you the idea here. Shallow comparison basically means when you compare two objects and you try to figure out if those two objects are referring to the same spot or space inside the memory. That may not be very clear, but I'm going to explain it later graphically, probably. So shallow copies, for example, if you have object X and you have object Y, and you try to figure out if they are both referring to the same object stored, they're just two identifiers for the same object inside the memory. Deep comparison is basically no, you compare the values of X with the values of Y, and if they match, you get a true. That's what we mean by deep comparison. Now, again, what is that supposed to mean? Now, let me just go ahead and use my painting to explain the concept. Imagine we have an object called X. Now, inside the memory, oops, my bad, I don't know, what did I click? Here we go. Imagine inside the memory, we have a spot, and this spot here basically is going to store X. Now imagine we have another object, which is Y. Now, if I come here and type, both of them belong to the same class. If I say X, let me just, if I type Y equal X, Now, in Java specifically, Java is designed to manage memory wisely. So when you say x equal y, what's going to happen in Java? Java is going to realize because x and y are going to be exactly the same, it doesn't make sense to have, let's say, a new memory spot to store y in it. Let me just cut y here. And store y. And we know that x and y, they have the exact same values. So it's basically a duplicated kind of memory. So what's going to happen, basically, when you type something like this, Java will actually use y to reference the same object that x is referencing. So basically, x and y are referencing the same object. So in Java, when you type y double equal x, or x double equal y, you're basically asking the question, are those two objects are referencing the same spot inside the memory or not? And in this case, that will be yes. That's basically how it works. So let's go ahead and change this. So I created x here, and then I will have the memory location for it. And x is going to be stored here. My skills in drawing, I do have a tablet, and it's really, really bad. So, and let's imagine we create a new object, which is y in this case. And now, instead of assigning assign x to y, I'm just going to use the new keyword here. So whatever x is, y is going to be the same. Now, when Java will see something like that, Java will decide that I am not going to reserve both objects to the same spot. Basically, Java would decide I will keep each one of them separated. And that's basically how it works. In this case, this is very important. If I come here and say x double equal y, this is going to be false. Why is that? Because you see this equal operator? This doesn't compare the value of x and the value of y and try to figure out if they match or not. Basically, it's going to see if x and y are basically referring to the same object inside the memory. And that's, again, how important this is to understand. The double equal basically will perform a shallow comparison. Okay, with that being said, let's go back and talk about the equal operator. Now, the equal operator, which is basically an operator or a method that's going to be inherited using the object class, acts like this. Oh, wait a minute, I'm not in the right spot. Let's do it here. X dot equals, and you put y here. Now, equals act the same exact way as the double equal. That's something you should know. The default implementation of equals acts the same way. So again, what is so special about it? What's so special about it is that you can change that if you want. And that's the beauty of equals here. You can change it, instead of making it perform a shallow copy, you can change it to perform a deep copy, and that's basically what you have to do. So let me just take everything away, and I'll just see you to understand. One concept. In Java, double equal, when you use non-primitive data types, will perform what we call a shallow copy. What does that mean? If I have an integer x and I have an integer y and I use a double equal, yes, the compiler will check the value of x and the value of y and compare them and give you the results. Again, x and y here are primitive data types, integers, characters. If x and y are objects, it doesn't matter what type of object. When you use the double equal, it's going to perform a shallow copy. Are those two objects referring to the same spot inside the memory or same object inside the memory? If the answer is yes, yes. If it's no, no. Now, equal, which is basically x dot equal y, will do the same job by default. What's so special about it then? What's so special about it then that you can actually override it and change it instead of doing a shell comparison to do a deep comparison. Now let's move on and talk about an example so that will make it easier to understand. And here we go. So what I'm going to do here, I want you to pay attention to this. This is id class. I created this protected integer x, and I have a default constructor where I'm going to set x to 0, and I have a public argument constructor where I'm going to set x to x. Okay, so let's go back here and see. So I created new id object. The first one will pass 10, the second one will pass 10. And I am going to actually check and see if id A and id B using the double equal operator. Now, let me just comment this section here. So we just focus on this double equal operation. Now, let me run it, and I am just going to focus on the last element here, not equal. Now remember here, look at this. This is integer A, id A, id B. I'm passing the same value here. So basically two objects that belong to the same class that share the same exact data member value. And I'm comparing, are they equal? The result is they're not equal. Why is it not equal? Because I'm using the new keyword, and because the new keyword, I am basically comparing and asking if those two are actually referring to the same memory spot. So let me just take this away and keep this one here. Now I said integer id B equal id A, and now if I run it, you would notice that they are equal now. Why? Because both of them are referring to the same object inside the memory. Okay, let's go ahead and use the equal, the default equal, and you will notice that the results are not going to be any different. So here, the equal. Now let's take this one away. And now they're not equal. So the question is, how can I make this one to perform a deep comparison instead of shell comparison? Well, here's the method that I already created, override it inside your. And by the way, there's something you can do here. Let me see here. This should be a keyword. I should not complain about this. I don't know if I No. There is something. I'll figure that out later. That's not a big deal here. Okay, so here you go. It's public. It's returned a boolean. It's equals, and you're going to pass the id other. And look what I'm doing here. I'm comparing this x with other x. Okay. And I'm saying if it's true, return. I'm comparing the values here, remember, because x here and x here, they are both integers. So if they're exactly the same, return true, otherwise return false. So let's go back here. After I did the implementation, you would notice that this basically would tell me, yes, they are equal. And here it is. The first one still telling me they're not equal. The second one here, function equals, is telling me A and B are equal. Let me change this to be 90, for example, and then you would notice it's going to give me a not equal. Both of them. Okay, so this is basically what the equal comparison is, and this is how it works. Again, the one that I was trying to show you here is you can write this. It's not going to compile or anything. It's just to give the person who's going to read it, the idea that this is basically going to be overridden. I'm not sure I remember what is it should be override, overwritten, overwritten. I don't remember the keyword, but I'm going to look into that and talk about it in the next video.